Aloha Physics 223. My name is Gregory King and I will be guiding you through problem 14.53 in our homework. So the background of this problem is that orangutans can move by brachiation, swinging like a pendulum beneath successive handholds. Now, if the orangutan has arms that are 0.93 meters long and repeatedly swings to a 23-degree angle, taking one swing after another, estimate its speed of forward motion in meters per second. While this is somewhat beyond the range of validity of the small angle approximation, the standard results for a pendulum are adequate for making an estimate. Okay, so we're going to start with what we know. And we know for a fact that I'm not going to be able to draw an orangutan. But a simple a pendulum-looking triangle will get us close enough. So I'm going to start with a color here. So we'll have a point at the top. And we will have an arm length of 0.93 meters. And I'm going to install a normal angle real quick. And you can use the law of sines if you like. There's a couple of ways to solve this triangle. I've already done it. And we come out with that will be an opposite side of 0.39. 5. Okay, I'm going to show that to you real quick. There you are. I know this is not the best angle for this, and I apologize up front. Okay, so we also know something else, and we want to write this down. We have the pendulum equation, because we're trying to find velocity, which will be related to period. And so t equals 2 pi times the square root of L over G. And L in this case will be our 0.93 meter arm length. Okay, so now we just set the equation up to solve for T, and we're going to do that real quick. Start off with by plugging in the numbers that we know. So T equals 2 pi times the square root of 0.93 meters, we're going to want to use units here, over G, which is 9.8 meters per second squared. And if you notice, we have, I'm sorry for that, a fraction under a fraction. So what we will do first to simplify that is that means that our second squared, I'm going to fix this, will, come to the top. So now our equation looks like this. T equals 2 pi times the square root of 0.93 m dot s squared over 9.8 m. Okay, now we've got a couple of things that clean up for us. One is that the units go away. They cancel each other out. And so we'll take that one step further. Sorry for that. T now equals 2 pi times the square root of 0.93 s squared over 9.8. Okay, I had to pause that for a second, I'm sorry. So now you can see we've already started a little bit on our workflow. And so now we're going to clean those numbers up. So we've got We're going to clear out that fraction first. So 0.93 divided by 9.8 gives us t equals 2 pi times the square root, I probably didn't have to make it that big, of, according to my Inspire, 0.095. We're going to cut that down a bit. It's actually a much bigger number, s squared. And so we're going to take the square root of that. And I'm just going to keep flowing with the numbers here, so if your calculations give you something else, sorry, it should be close enough because I'm rounding here for the paperwork. Alright, and that leads us to t equals 2 pi times, I'll put that in parentheses, 0.308. S. Square root of s squared is s. Units are cool like that. So I'm going to give you all another look at that for a moment here. Hopefully it focuses. Okay. And now we're just going to plug in our numbers here. So we're going to take that answer and multiply that by 2 pi. And that means our t equals 1.93, I'm going to call that 6 s, and that will give us our period that our orangutan is swinging at right there. Okay, sorry for that. I had to take one last break. Alright, so now we know that with each swing, with each revolution, the monkey's going to, or the orangutan is going to travel 0.395 meters. Let me put that in there. And we know that the period is going to be 1.936 seconds. So now we just need to find his forward velocity. And so velocity is actually pretty simple. It's just distance over time. So our v equals 0.395 meters over, we have 1.936 seconds right there. Yeah, this is going to be a little wobbly. And so what we will do is we will get rid of that scalar on the second. So 1.936 multiplying by the inverse over 1. Leads us to 1.936 times 0.395. Oops. That was a typo on my part. 0.395 leads us to 0.76, I'm going to round that to 5, m over s. Now, I did get a little different result from the Mastering Physics answer. They wanted me at our velocity equals 0.75 meters per second. So obviously we had a rounding error in there, and there's plenty of places for that. But that still gets us awfully close enough, considering that, according to the question, that this is making an estimate. So I hope I held your rapt attention close enough, and I hope this helps you out a lot. Let me know if y'all need anything else. Peace.